Well, good evening, everyone. My name is Bert Dicht. I am the Managing Director of Membership for the National Space Society. And on behalf of my colleague Larry Ahern, Vice President of Chapters, I'd like to welcome you to our Space Forum this evening, From Campus to the Cosmos, the EagleCam adventure. And I know you're definitely going to enjoy the session tonight. So as always, I'd like to just run through the agenda real quick. I'll do some virtual etiquette, then get into a few of our NSS announcements, then talk about what's coming up with our space forums. We've got a lot more work to do on getting the program going, but I'll share what we have. And then we'll get right into our program, and then we'll close out for the evening. So as always, in terms of our virtual etiquette, feel free to submit a question using the Q&A function. Again, that works best because we can see only the questions and it's easy to pull them out. So that's the preferred way to do it, but absolutely feel free to use the chat function as well. We only ask because that's seen by everybody that you can be respectful of both all of our panelists and the audience. We did get a number of questions that were submitted beforehand. I know our guests tonight will be covering some of them in their own presentation, but then we'll have a Q&A function, as I said, following that. So looking forward to that. As always, we appreciate those that support the National Space Society, both our volunteers and our donors. So if you're enjoying the program, like the Space Forums, please make a donation to support us. I will put that link into the chat as always, and thank everybody in advance for your donations and also your previous support. Finally, complete the post-Space Forum survey at the end. It only takes a couple of minutes. It's anonymous, and as I always say, it really does help us in terms of planning and providing the most valuable type of experience for you. So thank you in advance for that as well. So let me just do a couple of items in terms of what's coming up with the National Space Society. I know when we last talked, we talked about the ISDC, our International Space Development Conference 2024. This is the 42nd annual ISDC that will be held in Los Angeles, May 23rd to 26th. That's Memorial Day weekend. A great location, the Sheraton Gateway, Los Angeles, which is right near the airport. The theme for the ISDC is No Limits, and it's just 3 weeks from today, so we're really getting close. It is NSS's keynote event, and we've got an incredible list of speakers and panelists and other guests that are going to be there, covering everything from space solar power to many roads to space. And I'm just sharing this one slide with some of the key individuals that we have coming, 2 astronauts, Jose Hernandez and Susan Kilrain. We've got Dr. Pascal Lee, Dr. Claire Leone, who's from the United States Space Force, Dr. Alan Stern, who you remember was on one of our space forums last year. We've got Kelly Fast, who is the manager of NASA's Planetary Defense Coordination Office, and a whole bunch more. It's really an impressive group of speakers. And I know our presenters tonight are from Embry-Riddle. We actually have some student presenters from Embry-Riddle who will be there as well. So that's exciting. So as the saying goes, don't just dream about space, be part of the mission. We hope you can register for the ISDC today. Plenty of time still to make your plans, and we hope to see you in Los Angeles. The other aspect I don't have a slide for, I mentioned it at our last town hall, is that we are planning another tour of the Kennedy Space Center, and I'll be sharing a lot more details going forward, but we've actually picked the dates now. So it's going to be the weekend of September 20th. Actually, we'll have people come in on the 19th, that Thursday. We've got some great activities already in the works, both at the Kennedy Space Center and some other really good attractions and behind the scenes things that you normally are not going to be able to do. So we'll be sharing a lot more about that as the weeks go on. So look for that, and you'll also be looking for details in an email and through our Ad Astra downlink e-newsletter. So what's coming up in terms of our space forums? Well, next week will be the last space forum before the ISDC. So we'll be taking a little bit of a break. And we've got the launch director's perspective with Bob Seek. Bob is a great guy. He was a space shuttle launch director, was responsible for launching more than 50 space shuttles. And he's going to take us behind the scenes of what a launch director does, and also touch on a little bit about the difference between when you're launching a rocket, which we have a lot of rockets launching here on the Space Coast lately, but launching people, which is going to be happening on Monday with the first launch of the crewed Starliner. So it's a big difference, and he'll be sharing all of that in his perspective and what's going on with space. Working on a lot of different topics. We've got tentative dates right now for June following the ISDC, and we're planning things out in July and August as well. So hope to share more of that as we move forward. So now I would like to start talking a little bit about our program. And it's always great to have a program where you have a direct connection with, because we at NSS had a great experience with these students. We were all involved in the launch of Odysseus, the Nova C Intuitive Machines lunar lander back in February. If you recall, one of our board members, Chantel Beyer, actually had a payload on board as well, the moon phases artwork. So we actually put together a launch party before the launch, and we had a lot of students coming from Embry-Riddle who talked about the EagleCam in front of a great group of people, an audience. You see this picture up here. We have two of our two presenters tonight are in that picture. Grace Robertson, who's holding the EagleCam mock-up there, is standing next to Nicole Stott, astronaut. And we had a great time just getting to know these students, and we're able to witness the launch, the SpaceX Falcon 9 launch that sent Nova C on its way to the moon. So it was a great experience just getting to know them. So I'm really excited about today's presentation, because to me, this is, I was an engineering student as well, and to think about the fact that as an engineering student, they designed something that went to the moon. And they also have some interesting things to talk about as well as to what's coming next, because they're really involved in space as college students. So I'm looking forward to when they actually get out there and start working in the industry. It's going to be great to have them. So it's my pleasure now to introduce our panelists tonight. We were able to get an extra presenter tonight too, from when we initially advertised this. So let me just do a very quick introduction. First, I'd like to introduce Vikas Patel. Vikas is an undergraduate student at Embry-Riddle, majoring in aerospace engineering. He is an integral part of the EagleCam team, and also a 2023 astronaut scholar. So maybe he'll be able to tell us a little bit more about that as well. And we also have Daniel Lopez, an undergraduate student, senior as well, majoring in mechanical engineering, which is my background at Embry-Riddle, and also a critical part of the EagleCam team. And they're going to be sharing their experiences and also talking about the alumnus, which you're going to hear about the program they're working on now for Jared Isaacman and Polaris Dawn. So, gentlemen, it's my pleasure to introduce you. I know you're really busy with things going on right now with school and the alumnus project, so I really appreciate you taking the time to join us. So I'm going to stop sharing and turn it over to you.
All right, Bert, thanks for having us on. It's really nice to see or be able to talk about our experience and tell everybody else about what we're doing. So here we go.
Absolutely. So thank you all for being here, and we really appreciate you being willing to hear what we have to share in terms of our perspective of the EagleCam landing, as Daniel mentioned. So to start off, what we do at the Space Technologies Lab is we design, build, and create not only research that innovates what we do in aerospace from orbit estimation, but we also make payloads that go into space, which, in my opinion, is the most exciting part, right? And so with that, with operating those payloads and designing that, a lot has to happen in terms of the development, because what we do has not been done before. You can't buy this off the shelf, and everything has to be custom built from the hardware to the software, and most importantly, making sure that it'll work when it actually gets up to space. And so currently we have all the way from PhD students to undergrads, and even over the summer we were able to bring in some high school students, so that everyone can have a different level of experience and different level of way of connecting with the projects that we have going on. So our research that we do at the lab emphasizes on optical sensing and navigation, and especially orbital mechanics. And a lot of that ties into what we do with our payloads. We've had grants, and we've had 3 main flight projects, which we'll be touching on each of those throughout the night tonight. So to start off with our first flight on Blue Origin. So initially, we were scheduled to launch on NS-23, New Shepard 23, on, I think, September of 2022. And so this was a suborbital flight attempt, but it still passed above the Kármán line, above the 100 kilometers line that is declared as space. And the idea is to have the EagleCam hardware on board so that we can validate it not only through launch, but validate it in a space setting so that we can simulate microgravity and ensure that all of our payloads work in the setting that we'll be sending it up in. We had a couple of first-year students and even a worldwide student help us out in getting the project together. But as you guys know, space is hard, in a very famous quote. And so NS-23 in September of 2022 did not go as planned. And so when we had our payload aboard, it experienced some conditions that were much greater than what we had designed it for. And afterwards, we were able to send it back up on NS-24, and it was a very successful flight. We were able to bring that payload back and get the data we needed to make sure that we felt comfortable with where EagleCam was. There on the right, you can see Joseph Niklich. He is a Space Technologies Lab alumni who now works at Blue Origin, and he got to pull that hardware. He got to pull basically his own hardware off of the space capsule, where as a part of his job, which is absolutely incredible. It kind of a ashes to ashes moment where you saw something be created, and now at the end you get to put your hands on it to bring it back.
All right, so my name is Daniel Lopez, and I came in EagleCam in middle of 2021. It was fairly close to the conclusion of a lot of design and heavily into the integration period. EagleCam was a very massive project. It was 26 students total from a lot of different engineering backgrounds, some non-engineering. There was business students, there's a couple operational students, and it was 100% externally funded. And so when I joined, it was around August of 2021, and I was in the final stages of getting everything set up, finalizing testing, and I was actually part of the original integration team that went to Houston, Texas to deliver EagleCam and test it with their flight hardware. So this is just an overview of the team back in 2021. Maybe this is 2022. It's a fairly old photo, but you can just see how many people had hands on this. And this is just a fraction of the team too. There's a lot more students that at this point had already graduated. And then as we move forward, there's a lot more students that came on in the sort of operational standpoint, as well as documentation and stuff like that after delivery. So it's pretty nice to see the whole team grow as time moves on and kind of evolve with the needs of the project. So EagleCam. The EagleCam designed as a deployable that gives a third-person view of Odysseus as it lands. And we had a couple other things on there. We had a on this one we had a EDS, which is electrodynamic dust shield, that is actually a Kennedy payload that they designed for us and we attached on there. So we have the three main wide field of view cameras that capture stills at various exposures. And we had the EDS that would actually pretty much electromagnetically vibrate dust off of the lens. And that was a test of making sure that we could clear the lenses from lunar regolith after landing, because that's actually a really big deal that people are still trying to figure out. So we had commercial off-the-shelf components for our flight computer. It was also a really big thing for us. Being able to validate that these COTS components would function and send data back in the harsh environments of space was really big. It was also going to be the first Wi-Fi demonstration on the moon, because we had two main flight computers. We had one in the EagleCam itself that you see on here. And then the deployer has a secondary computer that actually is the main link from EagleCam to the lunar lander itself. So it's kind of an in-between a communication computer. And then power systems. We had to do a lot of finagling with the power systems so we could power the EDS, like I was talking about before. That was a pretty exciting thing to try to develop around and harness that within the volumetric and power limitations that we had. And we also had an IMU to capture the movement during landing. Once we would be ejected, we would capture all the dynamics, and we would actually compare that against our recreate it against what we estimated from our initial design standpoint and validate that that operated correctly. So we're planning on approximately 2.5 gigs of data, around 1,200 images, as well as a couple logs for the IMU and a few other things. One of the big things we did was we wanted to make sure that we would survive impact, because given the point which we would eject, which was 30 meters above the lunar surface, we had an estimated impact velocity around 10 meters a second, and a little bit of a jolt, you know? So we had to make sure that our structure, for one, survived and our electronics survived, secondly. So what you see on your screen here is actually a student came up with the idea to simulate this in ANSYS, and then as a practical approach to it at the same time, compare the data from ANSYS with real world information and experimentation. So what he did was he came up with what you see on the right here, Lucy, is Lunar Environmental Regolith Simulator, or might have gotten that wrong, but it's a test bed that's filled with lunar regolith simulant from UCF, and it's the same chemical composition and particle size distribution as lunar regolith from one of the Apollo sample returns. So we were using that as our top layer. We had some playground sand on bottom, and we dropped it from 30 feet here on Earth, which is equivalent to roughly 30 meters a second or 10 meters a second velocity on impact. We did some math, it was roughly 30 feet. And using the scissor lift, we were able to drop it in there and make sure everything functioned after that drop. And we even hit the side rails. You can't see in this photo, but there's actually a metal beam that holds all four corners together. And we actually dented that metal beam with our structure. So it's pretty fun seeing it survive the even higher loading than what we're anticipating. And then this here is actually a visual from EDS. So what you see is the first image is a clean lens. The second image is that lens being obstructed with lunar regolith simulant. The third image is it detecting it. So that's actually a photo while the EDS is operational, and it's a high voltage alternating current sort of vibration that happens with layers of wire between two panes of glass. And the fourth image is that newly cleaned lens after the EDS has finished its cycles. So it was really cool to be able to test that out on Earth and make sure that it all operated. So this is actually a photo of right before delivery. This is the final moments of assembly of EagleCam and integration. We had a couple tests run after this, but this is just like a look at us getting it all together, getting it done, and it's over. This was quite a few nights and all-nighters. I think this was maybe even a week and a half of us just cycling through the clean room, making sure everything operated, and making sure we kept a pretty clean environment for assembly. So this one here is between 2021 when we first delivered and 2023 when we finally assembled onto the Odysseus lander. So you see myself and another student, Daniel Posada. On the left, you see Dr. Troy Henderson, our faculty advisor. who's there to help us everything along the way. And on the right, in the middle there, you can see Steve Altemus, the CEO of Intuitive Machines, giving us the good old dad's thumbs up, letting us know that things are going well, and we're all really excited to see this happen. But it was for myself, it was really cool to be able to have hands-on hardware at their facility in Houston, Texas, and as well as working with their flight hardware, being able to be a part of the assembly process and see all that in person and be included as a student. That was absolutely amazing to me. So here's a photo of the closeout right before we wrapped it with MLI. Don't worry, those remove forward flight plans were removed, but you can just see, it's beautiful.
And so, yeah, all three of the astronaut scholarship winners from Embry-Riddle were in some way involved with the EagleCam project. So in the image from left to right, you see Nicole Stott, astronaut and Embry-Riddle alumni. She has come to Embry-Riddle a couple times in the past few years to give a talk and award the astronaut scholarship winners. There on the second from the left, you see Grace Robertson. She was the first winner from Embry-Riddle, and she had lots of hands-on time, especially with the hardware on EagleCam. After that, you see Jared Jordan, who again was very involved, and lastly myself. And it's just been incredible to get to meet all these people. And this picture actually was taken the night of the first attempt of the launch that NSS so gratefully hosted. And then, of course, we all got together. We were able to bring the entire lab together to go and see EagleCam launch, which is just incredible, especially in terms of team morale too, right? You guys worked so tirelessly on this one project, and we finally get to share that experience together of seeing it go not only to space, but to the moon. And so when it finally launched on the second attempt, maybe not the first attempt, but the second attempt, it was stunning. So we were about 3 miles from the launch at Banana Creek, and it lifted off from launch pad 39A just as planned. And in my opinion, the best part was getting to see the booster come back in a return to landing site mission, and not knowing when the booster was exactly going to be by, and then all of a sudden seeing the Merlin engines light and see a flame pretty much appear out of nowhere and propel itself to land right back just maybe a few miles from where it took off was absolutely awesome.
All right, so what you see here is actually a photo from Odysseus while we were, I believe this is actually shortly before landing. So you can actually see, I don't know if you can see my cursor on here, but on the bottom right, you can actually see EagleCam hatch closed. So this is, I believe, 400 meters, 500 meters, something like that, above the landing site. So this is on that final phase. You can see the sun, overexposing the camera over there. Pretty fun. And this is actually a photo. So this is a lot happening in this photo. If you look in the background there, you can kind of see that graph. That is a graph of battery when things start happening. So we have that up there as like just a reminder to see what's happening. On the screens in front of us, we had 2 large 55-inch TVs in front of us. That was displaying the live telemetry from the lander as it was orbiting, and we had some other information live streamed on the other monitor, other TV. And this is actually the moment when we saw the battery start charging. So this is a really big deal for us because on those last couple orbits, we had it pre-programmed to turn on the charging system where the deployer computer would start charging EagleCam itself. Ensure we got that topped off battery, and we also triggered a couple of our safety checkouts and health checkouts. We're able to transmit a file, so that was really exciting to see our work happening in that moment, and being able to see that those commercial off-the-shelf components were functioning just exactly as we designed and intended. So that was a really big deal for us and a really big moment. Landing was a little bit spicy. We were watching both the live stream and the telemetry at the same time. and we were following along, and we were seeing the same things Intuitive Machines was seeing. Pretty much that we were landing, and then it looked like we had landed. It looked like everything was upright. So just to go back a little bit and talk about some of the things that happened during this this flight, there was an oversight on essentially like a remove before flight sort of feature on one of their lasers for the laser rangefinder. And that's a really crucial component to their landing system, because that is their main source of altitude data. And as they were approaching the surface of the moon without that laser, they were practically growing in blind for all intents and purposes. So within the last couple orbits, they realized that they had this issue. And this was right after we'd been turned on. So we saw ourselves charging, we saw our batteries top off, and then everything go nominal. And we're watching what was happening on their end, and we noticed some stuff was like kind of not adding up to what we had expected. So we radioed in, we're like, hey, is something going on? Like, should we be concerned about this? And they're like, yeah, we're working on something. We'll give you a heads up when we have more information. So they actually, crazy enough, they reflashed their flight computers in flight to instead of using their laser rangefinder that was a part of their instrumentation systems on board, they used the NASA payload, I can't remember what it's called. There's pretty much the same practical application that NASA payload on board had, and they actually had tested, or I believe they had floated the idea of using this information within their own flight system. So there was some code already within the flight computer that was tested and tried with this NASA payload that also gave altitude data. So they did a emergency flash in lunar orbit, to go ahead and see if this could work. And they ended up piping in that data into their systems. And that was really good for a majority of the flight and for the majority of the landing. After a certain altitude, though, that data became no longer was like sending in accurately. So the last steps of their landing was actually through it was all optical. So they had cameras for determining safe landing sites and that sort of thing. And instead of using lasers, they're just calculating what their altitude was real time using those cameras, which is kind of crazy because it was never tested or intended to do that. So when the lander hit the surface of the moon, it thought it was at 100 meters altitude. It was actually at 0. So instead of going down at 3 meters or 1 meter a second, which was their plan, they have the vertical of 1 meter a second, and they had a horizontal of 0 was their plan. It came down at 3 meters a second and a horizontal of 1 meter a second. So that was a little bit out of spec for them, and it's not something they had fully intended. So we found out a couple days later, as well as them, once they got more updated telemetry and were able to figure out some of the communication issues they had because of the off-nominal antenna configurations. They found out that they had ended up sideways, and that was a pretty big deal. So using the information we had at that moment and that they had, we went ahead and did some simulations on what would look like if we had deployed sideways. Stepping back though, when they found out they had the communication or they had the altitude issues, they decided to let us know that, hey, here's what's going on. And we came to the conclusion together that for the sake of mission complications from the mission, and for just make sure we're focusing on landing, because that's our primary concern, we went ahead and powered our payload down because we don't want to be any sort of interference with an already complication landing. So that was a choice we made together to go ahead and do that, and then we would attempt deployment after landing. So fast forward a couple of days, we're doing simulations on what it would look like after we land sideways and if we were to deploy from this new attitude. And we can see on the left there, we're doing some simulation with the MLI we had used for Wi-Fi to see the penetration of Wi-Fi through the MLI, given this different configuration, make sure everything is still going to work. And then towards the end of the mission operations, we were able to get this picture transmitted, not us, but Intuitive Machines was able to get this picture transmitted of the landing itself. So this is actually fairly close to the landing moments. And you can see we're so close there. But you can see the damage on the landing gear there, the one to the left there and to the right, that one's also in a little bit of off-nominal configuration. And so it was a pretty spicy landing. And we were working as best we could to attempt a deployment, not knowing the status of all of our systems at this point. So in orbit, we're able to establish good communication with our payloads. We were able to transfer a file. We had a communication with Odysseus for our own internal system. After landing, when we attempted to boot up our computer, we were not getting communication. So there's a bit of a complication that happened there from the landing, and we did some investigation into that, and we're still getting more data too. We're still processing some stuff, but at this point, it looks like there was something that happened that we were not designed or prepared for. But that's what happens with first time landing. I mean, it's kind of absolutely incredible that we're able to be a part of this at that point in time. But anyways, we went through the cycles. We set some blind commands to go ahead and try to make sure that if there was anything that was functioning internally, we would be able to get data back. And so we went through all the commands to go ahead and power us up, enable data transmissions systems, turn on EagleCam, deploy us. And that final command deployment, we did see some response from EagleCam. So we did see some changes in temperatures that were very closely what we'd expect to happen had that hatch in the front opened up. So we do believe we were deployed, but unfortunately, we're not able to get any photos back to the prior communication issues I said before. And that's where we were with the EagleCam. So being a student-led project, a student-built project, and the first student project on the moon, I mean, we can't complain. It's absolutely incredible that we had this opportunity. And there's a lot more working with the two machines moving forward that we'll hope to share with you soon. And this is just one of the final images that they're able to transmit from the surface of the moon. So this is the opposite side of the lander. You can see the phase of the moon artwork right there as well. Installation on the side of the lander. So just for reference, we would be seeing pretty close to a 30-degree angle. So pretty much opposite of this tank here. We're pointed that direction. But yeah, it's still, even with everything that happened, it's still an amazing experience.
And so I was only able to come in like on the tail end of what was happening with EagleCam. But fortunately, we have another really exciting project going on with llamas. So as some of you may know, Jared Isaacman in the past has bought a space mission called Inspiration 4 that was a fundraiser for St. Jude's. And so he actually is buying 3 more missions called the Polaris missions, the first of which being Polaris Dawn, which is launching actually very, very soon. It's currently scheduled for summer 2024. And after he heard about what we were doing with EagleCam, he challenged us to create something for him to record the first commercial spacewalk ever. And the idea behind EagleCam is we have 2 stereoscopic cameras, so 2 cameras about eye width apart, and they each record 186 degrees field of view. And because they're eye width apart and because they have such a wide field of view, we're able to bring that data back and create a VR experience with depth of the whole spacewalk. And so the idea is that they turn us on using the button up top, and we record for about an hour and a half for the duration of their spacewalk. And then we can bring that data back once the llama's payload comes back down here and turn it into a VR experience, which will be absolutely exciting to see. And so it's the first university payload that's mounted inside the Dragon capsule. And on top of those cameras, it has a thermal camera, so we can get some live thermal data in terms of the suits, the capsule, and so that not only us, but SpaceX has some data to go off of in terms of the temperatures that are there throughout the entire capsule and on the spacesuits themselves. We have a radiation dosimeter, as they'll be in a very high orbit. And so it'd be great to see what kind of radiation they experience, especially as they go through the Van Allen belt. And one of the main things about llamas was the fact that the astronauts can basically set us and forget us. So all they do is they push that single button, and they basically step away and then complete their EVA. There was a lot of back and forth with that button in terms of what the astronauts would have to do. That one single hardware was the cause of a lot of discussion, and it was really interesting to think and to be part of that, and just to see how much discussion happens over each small thing that goes up in space. And in order to make sure that a mission goes successfully, you kind of have to do those things. You kind of have to nitpick every single thing that goes up just to make sure that it all works. So back in August, we were able to bring the astronauts down and have them and show them the qualification unit for llamas in person. And they also got to try on the VR experience themselves, which is absolutely incredible. And this right here is a picture of the llamas team. So last summer, we got to go out to SpaceX headquarters where they allowed us to use their facilities to do some of the more rigorous testing, like abort level vibration profiles, as well as get to use the Dragon capsule simulator they have inside to get some idea of what the lighting would look like, especially with us being a camera that's going to have to operate autonomously. It's really important that our camera gets the picture right the first time around, just so that the image is not too blown out from any sun that could be peeking through, and so that we make sure that we get the best experience possible for these astronauts. And yeah, that should be it for us. If you have any questions, please let us know. But it was a blast to get to show you guys what our thought processes were as we build these three space payloads, and hopefully soon we'll get to send our third one up soon.
Fabulous. That was great. Let me just ask a question. I was involved in aerospace for my whole career, working on fighter planes, and it was really exciting to see two planes I helped design fly for the first time. I go out to see a lot of these launches now, and everyone's exciting. I just can't even imagine what it felt like to know that you had a payload on board that rocket. So can each of you just share what that felt like, knowing that something you have is on that rocket that's going to the moon?
Yeah, it was surreal. I mean, I had been involved in a lot of the integration and hands-on hardware for the lander itself, so I knew it was happening. And in your mind, you see it and you understand it, but you don't really believe it until you see it actually in the air. And it's just really that moment where it makes it real. It didn't feel real until we saw it in the air.
Yeah, and just as you might have experienced with the YF-21, getting to see something you made go up and fly is incredible. Because not only did you work on it, but the whole process of creating it, you work with this team to send it up, and so getting to share that moment was extra special. Absolutely.
Fabulous. Question to the both of you. What got you interested in, a STEM career and maybe specifically a space career?
So I actually started as aerospace engineering. Well, as a kid, I was involved with a lot of art processes and art programs. So I did a lot of 3D modeling. And back before SketchUp was bought by AutoCAD, it used to be run by Google. So I did 3D modeling. I remember as an elementary school student in my art class, I submitted a 3D art project, which was like a 3D model Jeep, something pretty simple and basic, but it really got me involved with the science aspect of it. And so when I first started at Embry-Riddle, I was aerospace engineering, and I felt a little bit concerned about what I was going to do moving forward with like mobility within defense industry jobs. So I was trying to figure out what if I wanted to do that, or if I wanted to switch into something a little bit more robust with mechanical engineering. And I actually ended up switching mechanical. And funny enough, it became high performance vehicles, so it's combustion engines, and then with all the stuff with electric vehicles and all that, it became kind of one of those careers that's almost niche. You don't know what the future is with all the politics involved. So going back into space was kind of this funny 180 that happened. And as a kid, I was super interested in space. I loved seeing the videos of the shuttle and the Apollo missions, and I thought that was super cool. So being able to actually be involved in that as an adult and start my career with that sort of stuff is incredible.
Yeah, and me personally, kind of same thing. Growing up, I've always been interested in space. I think I've been wanting to be an astronaut since I was like 6 years old, And so that kind of drive to not only explore what's out there, but be involved in the mathematical, the engineering processes that goes into creating the incredible launches, the incredible missions that we see. That was always a driving factor, just to be able to say that, hey, something I worked on has gone to space, and something I worked on has been with humans, and it's really fortunate that I get to do a lot of that as a student. Absolutely.
Fabulous. I'll tie into one of the questions that was in the Q&A about recommending someone to attend Embry-Riddle. How did you choose Embry-Riddle? And obviously, from what you've experienced, Embry-Riddle is a great place to go. So what would you say to recommend to a student looking at where should I learn engineering?
Embry-Riddle is a great school. I mean, there's a lot of opportunities, and I think one of the strong factors of Embry-Riddle is how much access undergraduates have to research projects. I toured quite a few different schools, UF and quite a few other Florida State schools, and definitely seeing the accessibility to doing research before starting a graduate program. That was a big plus for me, and pretty much a deciding factor in joining Embry-Riddle.
Yeah, and so my brother went to Embry-Riddle back when he was in school. Graduated in December of 2014. Funny enough, so coming up on 10 years now, and that's kind of what was driving me to go to Embry-Riddle of all places. But on top of that, it's great to see that Embry-Riddle not only in Florida but around the whole country produces amazing engineers. Not only research engineers, but most importantly, engineers who get their hands on things from competing in the AIAA Design Build Fly competition to working on space hardware. You can do pretty much everything you want and get a lot out of it in the process.
Great. Let me ask you a little bit about EagleCam and the design work that you had to do. I know in talking to Chantel, who had that payload for the moon phases, she said that leading up to the launch, she was in constant contact with engineers at SpaceX because they kept asking questions. And I said to her, well, isn't it a little too late because it's already, the spacecraft's already on the rocket? So, but I just want to know how much involvement did SpaceX have in terms of design criteria, what you needed to make sure of, because they obviously wanted to make sure their rocket is fine, but and I think that's what they were asking Chantel about. So, and I never thought about all the things that you have to think about when you're launching a payload into space. So I just want to know if you had any experience like that with interacting with SpaceX.
So a lot of our design criteria was given through Intuitive Machines.
Okay.
That was our basic concepts and our requirements through that. And then we had somewhat similar experiences where towards the end, they're like, hey, do you have data? We didn't ask for this specific piece of data, but we need something supporting this or showing that you did this testing and this testing. So that was definitely towards the end, after assembly and integration. That was something that we worked with. But as far as the actual design, pretty early on, Intuitive Machines was in charge of like disseminating the requirements from SpaceX within their rocket to our payload, and then vibrational, for example, vibration that we might experience on the payload or on the rocket during launch was through Intuitive Machines and not the SpaceX side. So definitely like towards the end, and that was more so when we had interaction there.
And Daniel mentions the vibration profiles. That's one of the strongest things on our Llamas project that we have to deal with. Just making sure that it's strong enough, not only the main structure outside, but everything inside. These delicate cameras, these delicate computers, making sure that they can handle these insanely high G profiles that we have to do as a part of the testing. I think it's about like 48 Gs RMS, which if you know anything about what that looks like, it's absolutely incredibly high. And the fact that we have to make sure that these small components have to deal with that has been a challenge, but it's been a large learning curve for sure.
How about in terms of the temperature swings on the moon and the potential radiation? What did you have to do in factoring those into the design?
So for the temperature swings, we have a thermal vacuum chamber within our facilities in the lab. So we're able to do testing, component-wise testing within our lab and make sure that each component survives. And then for radiation, funny enough, the radiation profile we experience on that 6-day transit and 1-day operations was pretty low actually. So we're able to simulate that same radiation profile through cesium pellets in close proximity to the computer. That was the easiest way we found. And then we did some computer architecture choices that was going to help with some of the radiation effects. So not quite latching, stuff like that, but bit flips. We had error correcting memory as a basic component of our design and our computer for our flight system. So it was pretty much playing the game of statistics and hoping that we weren't one of the unlucky ones, you know?
Just like to understand a little bit more about your interaction with Intuitive Machines. You talked a little bit about the landing and the fact that their laser rangefinder was not working, and then they tied into NASA's LiDAR payload. And I personally, I think that was one of the most amazing things, to be able to do that on the fly in such a short period of time. But you know, what was it like working with a company that didn't even exist before 2013 in terms of the engineering, their approach to problem solving, things like that?
Well, I think definitely them being a new company doesn't mean they don't have the experience, because they're pulling in a lot of heavy hitters from a lot of different industries. And I think that was a big thing for them, was being able to pull this expertise from all over the industry that's, I don't want to say it's matured, but definitely grown over the past decade. Getting some of that input and being able to pull in new people with experience, help them make some of these pretty crazy designs work. And being a new company gave them the flexibility and freedoms to push through as fast paced as they did, something that might take, 20 something years at NASA. So I think the newness and the smallness of the company kept interactions close internally, and definitely made it was a warm company to work with. Like, it was easy to approach and it was easy to communicate. And I think that was a really big thing for them too.
Great. Let's see. I think there are a couple other questions I want to cover, but I want to go to a couple that were submitted in our Q&A. Carl asked a few questions about what part of the missions were you in direct control?
For direct control, so we didn't send any commands to the lander. That was part of one of their design criteria, was they would handle the control command side. However, whenever we ask questions or ask them to change things, that was done as quick as they could. So we had a couple periods where we changed some thermal set points based on different environmental data. We just like gave them a call through their communication system, and we're able to see that like apply instantaneously. So
Great. And is the camera still working now in any way?
I would be very surprised if those batteries survived lunar night.
Okay. Was it able? Yeah, I guess once it was would have been detached from the spacecraft. It was totally on its own internal power, right?
Mm-hmm.
Right.
Mm-hmm.
Great. In terms of what you learned, this is an exciting project to have been part of, and what do you think you learned the most out of it in terms of moving on to this Llama project?
Yeah, so I guess from what I got to see in terms of the lessons through integration and assembly, they did a very good job at making sure that the whole team was involved and making sure that the steps were pretty procedured in terms of getting all the components together and making sure that we got the final unit assembled in not only a timely fashion but effectively as well. But in hindsight, I guess not only learning from our own things, but learning from what IM, has done. Process is obviously the most important thing in aerospace, right? Making sure that you hit your checklists and make sure that you hit your documentation right, so that you can ensure mission success. And so, getting to learn that via IM's activities, making sure that we can take those lessons and incorporate that into llamas, going through thorough testing, going through thorough documentation, and going through thorough checklists just to make sure that we hit all of our criteria and we keep our llamas payloads safe for not only the mission as a whole, but especially for these astronauts.
Was there any point or any part of this where it was particularly a big challenge, like, hey, how are we actually going to do this? Did you ever encounter anything like that?
Every day.
Every day.
I think
Great, honest answer.
no, there's a lot of things that you come up with an idea, and EagleCam being our first major project. I mean, we had the Blue Origin one that was pretty much a technology demonstration for EagleCam, but EagleCam was our first major, orbital, post-orbital flight. And seeing some of those lessons we learned from that and incorporating that into new payloads definitely is really big for us. I mean, thermals are absolutely crazy in space. I'm sure you're aware. And that's a big thing that with our COTS components, you have to make sure we keep what needs to be cold, cold, what needs to be hot, hot. So that's one of those things that until you do all the testing, you don't know what's going to happen with some of these COTS components, You can do an estimation, but until you put it in the TVAC and you put it to -100 or 200 Celsius and you see what's happening with it, you won't be able to make a fully, educated mitigation or a fully, properly handle that environment until you experience it. So I think that's a really big thing for us. Lots of testing, testing, testing,
A lot of this work happened during COVID. How did you guys do that?
There's a lot of supply chain issues we had and Intuitive Machines had as well. So when COVID first set in, there was definitely some disruptions with design processes. I remember the first time we went to, or the team, not myself, but the first time the team went to Intuitive Machines was early 2020, and then we didn't go back until late 2021. So that big gap there definitely caused some complications with design processes and stuff like that, and getting everything assembled. We were able to work through it as best we could, finding alternatives to existing designs we had in place, and just trying to do as much science and engineering as we could to overcome some of these hurdles.
One of the questions Carl asks is about the persuasion you had to use to get your project accepted, but you didn't really need to do that. You were actually challenged by Steve Altemus to do this, right? That he came to campus, and as you said, he's a Embry-Riddle grad, and said, "Why don't you design we want a camera to take the first selfie on the moon."
Yeah, no, I know these first photos are really important for Steve and Intuitive Machines as well as for us. And I think that's moving forward with Intuitive Machines. I do expect it to be continued partnership where we will get not only these photos, but possibly videos too, which would be a very important thing for both of us. And no, Steve's been absolutely great to us and really appreciate the opportunity he provided.
And how did Jared Isaacman find out about you guys? He was just paying attention to the flight, or did it actually happen before the flight?
Yeah, it actually happened. Sorry,
Okay.
it actually happened before the flight. So, as most of you might know, John Krause is an absolutely amazing space photographer.
Fabulous photographer, yes.
Absolutely.
Yes.
And so he's the media relations officer for the Polaris Dawn mission and the Polaris program. And so he heard about what we were doing with EagleCam because of our good relationship, and he carried that along to Jared just because it's an incredible thing to be able to send something to the moon as as students. And so after Jared heard about it, he knew that he wanted to do something similar for his Polaris Dawn mission, and the rest was history.
Wow, that is fabulous. A really exciting time for you guys. Vikas, why don't you just tell us a little bit about the astronaut scholarship real quick? You're the 2023 astronaut scholar from Embry-Riddle.
Absolutely. So every year they have a new cohort of astronaut scholars from all around the country. Just last summer, they had 68 scholars from everywhere from University of Washington down to Embry-Riddle, California schools, as well as MIT. And so it's a very large range of students that get to be picked for this scholarship. And as a part of the scholarship, you get money for school, but on top of that, you get to meet some incredible people from astronauts to other leaders in the aerospace industry. And in my opinion, one of the greatest benefits is the mentoring. Every month, I get to sit on a 30-minute phone call with Chris Ferguson. He is a 3-time shuttle astronaut, 2-time shuttle commander, and even after his NASA time, he got to do a lot in terms of the Starliner program, which of course is launching in 4 days. And oftentimes we spend most of our time just talking about flying and talking about, how much we love being up in the air. But being able to connect with the people not only leading in airspace but leading in STEM around the country is an absolutely amazing achievement, and I'm truly fortunate to be a part of this amazing cohort.
Great. I see there's a question in there. If you could go back to the start of the project, is there anything you would change now, knowing what you know?
So some of the cameras we're using were stills only. There's some challenges with that. And we've moved on to a new camera company and camera system with llamas that has been absolutely phenomenal, because this way we get full hardware access to the cameras to do exactly what we say when we say, which was kind of a challenge with EagleCam. So being able to do that and the ability to capture video as well, we're talking above 4K, high resolution, high frame rate video is a really big deal. And one of the trade-offs we had is that those cameras aren't fully space rated, but given we have the facilities we do on site, we're going ahead and we're testing them to those same environments that would be equivalent to space, thermal, vacuum, a little bit of radiation. And we can go ahead and see what those cameras do within these vibration. We can see what the cameras do and how they respond to temperature and stuff like that. So being able to incorporate more COTS components, but then do the testing to ensure that they function as we need them to, with the higher fidelity and higher quality media output, is a really big deal for us. And definitely moving forward, we intend to stick with this new camera manufacturer.
Great.
And yeah,
Go
sorry.
ahead.
And on top of that, as Daniel emphasized, the testing, right? You can, especially in aerospace, you can never test something thoroughly enough, because once you send it up into orbit or send it to the moon, it's basically hands off at that point. And you need to make sure that it works not only the first time, but it works reliably. And so, just more thorough testing. If you have extra time on a project, the best thing you can do is throw more time at testing on it.
Actually, we'll add on to that a little bit more too. A big part of our budget for EagleCam was those cameras that were space rated already. And even though we had complications with them, they were certified to function in that environment. But we were able to, at this point with llamas, come up with 4 complete builds for under the price of those cameras, including the new cameras and flight computers on llamas. So that's a really big thing for us, is we can build more and we can break more through our testing and see what the absolute limits of these components are and ensure that it will operate. So bring that price point down for us was a really big deal moving forward.
Very good. Well, as we get close out the evening, I'd just like to talk a little bit about what's coming next for you. You're both, I believe, seniors. So, what's next? Where do you hope to be in terms of the space industry? So I'll let each of you take a chance on that one. Take a try on that.
Yeah, so I'll personally be applying to master's programs. So I graduate in December 2024, and I'll be applying to different master's programs. And after I complete a master's degree, I hope to join the industry in a GNC position, and eventually have something that I can say that I controlled this object that's in space.
Definitely very impressive. And you, Daniel?
So I will be joining the master's program at Embry-Riddle, and I will be continuing with some of these projects moving forward as a lead engineer position, which would be a really big thing to be able to contribute more and contribute back to the lab for what they've given me.
Fabulous. And so a final question for you both. Based on your experiences now, it's really impressive. I mean, what you've done is what people who've worked in the industry for 30 years would like to have achieved. But what advice do you have for students who are studying now, or maybe students in high school who are aspiring to become engineers, to be able to follow in your footsteps here?
Yeah, so in my opinion, the thing that's always worked best for me is trying to be involved as much as you can. There's no substitute for time and learning in terms of especially aerospace. There's so many people that have experience, and the best thing to do is just try to gain that experience and learn as many lessons as you can from them, so that you don't have to make the same mistakes.
Great advice. Daniel?
I think don't be afraid to get your hands dirty with some of these engineering problems, you know? Your car breaks, go out there and try to fix it yourself, figure out how the system works, and really dedicate time to make mistakes and figure out how you can improve your own skills and how you can apply things you learned like that elsewhere. I think a big thing that helped me get to where I am is I worked at a car dealership or a car mechanic for a while. I did that for a couple of years, and that was a really big way for me to see, you know, some of the common engineering problems that are faced in a certain industry and how people like technicians experience those problems or how they try to remedy them. So that hands-on was really crucial for me in my development. And I think hands-on is really what you should try to achieve.
That's a really good point. When I graduated from engineering school, mechanical as well, and started going out and designing fighter planes, it really amazed me how you went from an engineering design to going out there to see something actually being built. So you were actually involved in that whole process, which is really exciting. So I see that benefiting you greatly as you enter the industry. And I lied. I said I had one last question. I'll ask one more because I know, Vikas, you're talking about you want to be able to fly in space sometime. Same for you, Daniel. You want to hopefully fly in space?
It's not a huge goal for me. I mean, if I have the opportunity, I won't say no. That's for sure.
Okay. You and me both, right? But there are obviously going to be a lot more opportunities for people to fly in space, as Jared Isaacman is showing. Of course, hopefully you don't have to be a billionaire, right? But
it certainly helps.
It helps right now, but I think
absolutely
it is going to change, and maybe you don't have to necessarily be a U.S. government astronaut anymore. So Sierra Space, Axiom, there are lots of opportunities now, and hopefully we'll see you out there. And I know you guys, I feel very confident about the future of the profession, knowing you are going to be involved. So I really want to congratulate you on an amazing accomplishment. I'm still in awe of it. And just say thank you, your entire team, your professors. A truly spectacular accomplishment. So, and we really appreciate taking the time to share this with us. Is back. Okay. There we go. Perfect. We'll just splice that. I think the biggest challenge for me was not technical. The biggest challenge that I encountered was overcoming what I'll call we've always done it that way. And when I worked on the Advanced Tactical Fighter, it was the most exciting thing you could do as an engineer, because we were doing new things, exciting things, and no one was saying you can't do that. And I think that's a thing that has emerged from from new space and all these new companies about doing that versus potentially the legacy. And when we lost the contract and I went over to another program, I encountered a lot of that. Oh, well, did you ever think about doing it this way? Well, why would we want to do that? We've always done it this way. And I think that was a real challenge. So I would just encourage you, when you get out there, there might be times when you want to do it the same way, but it should never prevent you from looking and exploring new ways to do it, because that's what we do as engineers. And if we're gonna create these new space settlements, it's going to take a lot of different thinking, and not just, oh, that's the way we've always done it. Just just from the example, you know, again, I think just the example of intuitive machines when they had to figure out how to change over to the LiDAR from NASA, that was just brilliant, brilliant thinking on their part and being able to incorporate that. So that's the message I would have. And because I didn't really know about that when I started out as an engineer, but encountered a lot of it.
Thank you.
Yep. Well, very good. I really do. Again, Vikas and Daniel, thank you so much for joining us tonight. It really was very informative, very enjoyable, and wishing you both great success in not only your school studies, but with the Polaris Dawn mission and Llama. So we'll be watching that. And if you are coming down for the launch, we'll get together, right? If you
Definitely
to see the launch, right? So everybody, again, thank you so much. I do want to thank my colleague Fred Becker for doing everything in terms of our technical support, and of course my colleague Larry Ahern. So let me just share my screen one last time, everybody, as we close out for the night. Here we go. There we go. So let's just advance this. So again, it was a great evening. We thank you both for joining us. But everybody else, thank you so much for attending. For those of you in today's time zone, have a great evening. If you're in tomorrow's time zone, have a great day. And of course, a great weekend, everybody. Stay safe. We'll see you again next week for a great talk, the Launch Director's Perspective with Bob Seek. So everybody, thank you so much. Have a good evening.